Oh, hello. Well, welcome to Mr. V's isolation show, science show, reading poetry kind of episode 5. Today, as you can see, I've got it all figured out. I can actually read everything on here. Today's episode is going to be about Bernoulli's principle. Now, I even have, we have, look at this, graphics that go across Bernoulli's principle. And it's principle because it's a scientific principle, not the PAL. That's the person at your school that kind of runs everything. That ends with PAL because they're your pal. But this is Bernoulli's principle. And it's going to lead into why things fly. Because it needs lift. And we're going to get into some paper airplanes that you're going to build on yourself. And I'm going to show you the demonstrations. And I'm going to make you do them at home. So caregivers and parents, you got something to do. I don't have to do it all work. So, Bernoulli. It's a little simple little process here. Bernoulli's principle is faster moving fluids, and air is a fluid, so I'm just going to put air in there. Faster moving air has less pressure. So what does pressure have to do with flight? Well, air has pressure. It's pushing down on you right now. And I'm going to show you. So first of all, I have a pop bottle and a funnel. The funnel's coming in later, but I need hot water. So I'll pour some hot water in here. And hot air has less pressure because the particles are far apart. Cold air has the particles all close together. So if you watch the weather, they go, we have a high pressure or a low pressure coming in. That's dealing with, so I'm going to put some hot water. See, look, it's -4 here in Camrose. So I'm going to put this in there. Try not to burn myself. And all I'm doing is just going to heat up the inside of this little container here. I'm going to make the air in here, which was -4. I'm going to make it nice and warm. Yeah, nice and warm in here. Yeah, let's get that nice and warm. I'm going to put the top on. I'm just going to leave it here because I'm going to show you that air has pressure. I'm not going to touch that puppy. I'm going to let the air push on it. If it doesn't, big deal. You're just going to have to believe me. So Bernoulli's principle has a few things. Faster moving air has less pressure. So every demonstration I'm going to show you, it's going to happen the opposite way you're going to think. So a lot of times I'm going to ask you to take a guess at what's going to happen. That's making your hypothesis. What do I think is going to happen? And guess what? Hypothesis can be wrong. You're going to make a prediction. You're going to predict that this is going to happen. Yeah, if you're wrong, big deal. You've learned something. So the first, whoa, did you see that? I didn't touch it. The air outside is squishing it. Yeah, air has pressure. First thing we're going to do. Now, you don't have to do these all now. You can watch, and then you can play it back, since it says live, but then it goes on there, and this is just getting crunched. So faster moving air has less pressure. First one, little piece of paper like this. Now, I'm going to put it by my lips, and I'm going to blow over the top. So now, of course, you're thinking, well, if he blows over the top, it's just going to go down. Yeah, probably, but when I blow, I'm going to make the air go faster. So watch. Faster moving air has less pressure. You notice I had my pinky up too? So that's, you need to have your pinky up. Manners to do it. Faster moving air has less pressure. Find a funnel and a ping pong ball. I don't have a ping pong ball. I have a lot of them back in my old classroom. I don't have any here. But if you have a ping pong ball or a light ball, like I could try this ball, like Rocky's ball here, but this is too heavy. This is kind of too heavy, and if I put it in here and I blow, it's not going to work. So I'll just chuck it out there in the yard and Rocky will get it. I'll try with a balloon, but you take a ping pong ball and put it in here, and then you blow. And of course you think it's going to just shoot right out. I'll try it with this. Okay, so is that going to make it in? And the wind's going to blow it. That's not going to work. Ping pong ball. Try it. Something light, push in there. You think it's going to fly around. But you're going to get faster moving air around the ball, less pressure. Something's going to happen. Here's one. This is one you have to set up at home. This is one I'm not going to do for you. I'm just going to set it up here. I'm losing my toilet paper. Rocky, you don't need to get the toilet paper. That's expensive stuff. Okay, what you need is pencil crayons. They got to be the round ones. They got to be the round ones, and you get two cans. They can be pop cans or other cans. You see? They got to roll. They got to roll, and you put them apart like this, and you take a straw. It's another thing I don't have. I don't use straws. I have a mouth. I drink out of it. But anyway, you blow in between these two. Predict what's going to happen. So your air is going to go between the two. Predict what's going to happen. Now do it and see what happens. See if Bernoulli's principle, which is pressure, works. Faster moving air has less pressure. Less pressure because the air has pressure. Now, toilet paper. If you've got lots of this in your house because somebody bought a lot of it, go take a bunch of the rolls and put it on seniors' front steps. That'd be a good thing to do. Take a blow dryer. Make sure you got something that you can let it like roll in here. One thing that really works is one of those paint rollers. Put it in there. Now, I don't have a hairdryer. So you get a hairdryer with some toilet paper and a dog that knocks over all your experiments. Put the blow dryer right here, and as you see it's windy out here. Turn the blow dryer on and see what happens. But if you've got a leaf blower, take the leaf blower and have it blow over top like this, but make sure this can go. And you'll see how Bernoulli's principle works. That leaf blower, but they probably won't let you do it because everybody wants their toilet paper. Okay, here's one. I've got this former ticket that's for the Canada Cup of Curling that I chopped up, and I put a pin in it. See, here's a little pin and spool. So if somebody sews in your house, you'll have these. I have these. I don't sew, but I tie flies. I tie flies to go trout fishing, so I have some of these. So I'm going to put this right in here. Now, I'm going to blow into this, and what do you think is going to happen? Yeah, that thing's going to fly right up. But I'm going to even go this way. That should probably really make it shoot, shouldn't it? Watch this. I can't make it go. If I blow into it, it stays there. If I go like this and I blow into it, it doesn't go flying up. Does it, Rocky? No, it does. No, don't eat that. Don't eat the experiments, okay? This is, look what you did. Okay, yeah, and there you go. Why did this not go? Faster moving air came up in the bottom of it. That was less pressure from the air above. So that's kind of how things work. So, what does this have to do with flight? Well, if you take a look at an airplane wing, it looks like this. And air comes like this, and air likes each other. So when it splits up, it's got to catch up to itself over here. So when it goes around here, this is straight. This is a longer distance. So it has to go faster. So it goes a lot faster. Faster moving air has less pressure. That's less pressure up here. That means you got pushing up here. That's called lift. So that's what's going to make your paper airplanes go. Now, go online and look for some paper airplanes and build some. Go out and test it. Throw it. Now, if your paper airplane just goes, you're going to need more lift. So what you're going to have to do is try to get your wings working like that, or you can cut little elevators in them. Now you're thinking elevators, we're not in a big city building. Now, this is your elevators. When you're on an airplane, you put little elevators in here like this. And you can also go like this, put a rudder to make it turn left and right if you want. Now, you're going to go out and test your airplane. It might not fly very good, so keep adjusting it. Play with these things. Then get a hula hoop in your house and start throwing it through the hula hoop. Go outside in the backyard, or if you're in an apartment, maybe fling them off the balcony. I don't know. So you're going to test these things out. There's tons of books that you probably ordered from Scholastic at one time or another. Go dig them out and start building them. Take your airplanes and fly. Now, I'm just going to chuck these because, Rocky, want an airplane? Huh? Want an airplane? Okay, so I'll see how my airplane's. Yes. And the airplane is being eaten by a dog. Yeah, good boy. Here's another airplane, Rocky. Now the weekend's coming up. This is a lesson I can't teach you, but this is one I want you to look up. And probably all weekend you can do it. Take a look at Rube Goldberg machines. My former students loved it. We did a whole week. We had to make them. I think we had a whole process that had to work, and you had to bust a balloon at the end of it. Go look at all the videos. There's even advertisements. Once you see one, you're going to go, I've seen these before. Rube Goldberg was, he wrote cartoons, and it was all big machines that took forever just to do something like make his toast in the morning, pour his coffee. So there's a whole bunch of these. Now start looking at the ones that kids and everybody else has made and start doing that all weekend. I can't teach it. You teach it yourself. Get your Lego out. Get all the stuff out and step by step set up a Rube Goldberg. There's your whole weekend planned right there. Tomorrow I don't know what I'm going to do. I might do fingerprints and maybe some more reading of poems. I don't know. But I'd like to thank you for coming out here and helping out, and try those out and see what happens. Thank you very much. Bye-bye.